So I've already written the terminology used when naming parent chains and substituents. When naming parent chain depends on the number of carbons it is. Let's say it's 3 carbons, it's going to be pro at the beginning of it as the prefix. If it's 5 carbons, it's going to be pent, and so on and so forth. So meth means 1, F means 2, pro means 3, but means 4, pent means 5, hex means 6, hept means 7, oct means 8, gnome means 9, and dec means 10.
The definition of an alcohol is an organic group that contains a hydroxyl group attached to an alkane type carbon atom. As you can see here, we have 2 carbon atoms with an OH group attached to it. Now let's go to Jared with how to name them.
Okay, so today we're going to talk about naming alcohols. The first rule is when an IUPAC rules are used to name an alcohol, the parent chain, the longest continuous carbon chain carrying the OH group, is numbered from the end nearest the OH and named by dropping the E ending on the name of the corresponding hydrocarbon by adding OL of an alkane group, and this is pro 1, 2, 3 carbons. Okay. So for this example, I'm going to go ahead and add the OH right here on this carbon. Then I'm also, by naming an alcohol, I'm going to drop the E, so shoo, gone forever, and add OL, propanol. But we're not done yet, because we need to signify where the hydroxyl group is. So when numbering the carbons, you number from the end carbon of the parent chain closest to the hydroxyl group. So this would not be 1, 2, 3, but instead it would be 1, 2, 3. So in this case, it will be 1, because it's located in this carbon, propanol. So our second rule for naming alcohols, when a carbon chain contains more than 2 carbons, the position of the OH group must be specified with a number. So over here I have a hexane molecule, and that's because it's made up of 1, 2, 3, 4, 5, 6 carbons. Now we're going to change this into an alcohol by adding the OH hydroxyl group right here. Now right now I'm violating the octet rule, so I'm going to erase one of these H's. I'm also going to start off by dropping the E. So it's gone, erased, whew, gone, and adding OL. But again, we're not done yet, because we need to number it because it has more than 2 carbons. So we're going to number it from the end carbon on the parent chain closest to the hydroxyl group. So we're not going to number it from here, or rather here, because this carbon is closest to the hydroxyl group. 1, 2, 3, 4, 5, 6. So this would be 2 hexane. Oh. So when naming alcohols, any alkyl groups attached to the parent chain, also known as substituents, right here, are identified by name, position, and number. So over here we have a figure of a alkane group that is 3-methyl octane. So first off, I'm going to switch this to an alcohol by adding right here. Now normally, if it was just an alkane, you would number it from the end carbon in the parent chain closest to the substituent. But now, that's an alcohol. I'm changing that. So first off, we'll come back to this substituent later. And we're also going to drop the E. Add OL. E's gone. Done. 1, 2, 3, 4, 5, 6, 7, 8. parent chain is a chain that contains the hydroxyl group and the most carbons in it. And this is, in this case, 1, 2, 3 octanol with a substituent that's located on the 6th carbon of the carbon chain, and it contains only 1 carbon, so it's methyl. Don't forget your dashes in between the numbers and the words when naming alcohols with substituents. Just naming alcohols, period. 6. So this is 1, 2, 3 octanol, 4, 5, 6 methyl, 6 methyl, 3 octanol. So here we have some examples for naming alcohols. We have a line bond structure, a condensed structure, and a skeletal structure. Go ahead and pause this video and try naming these alcohols yourself.
Go.
So here are the answers for the examples. This is 4-methyl 3-hexanol. I'm going to tell you why. Again, when numbering the parent chain of the alcohol group, you number from the end carbon closest to the hydroxyl group in the parent chain. So be careful, because the parent chain is not always straight across. Remember, it's the chain that contains the hydroxyl group with the most carbons. So this is 1, 2, 3, 4, 5, 6 hexanol. 3 methyl, because it only contains 1 carbon. 4, because it's located on the 4th carbon of the carbon chain. 4 methyl 3 hexanol. Over here we have a condensed structure. Again, same techniques, same skills. Pentanol, 2 methyl, 2 methyl pentanol. 1, 2, 3, 4, 5. 1, 2. Over here we have a skeletal structure. And it is 1, 2, 3, 4, 5, 6. In the parent chain, total number of carbons is 6, so hexanol. The hydroxyl group is located on carbon number 1 of the carbon chain, so 1 hexanol. Then the substituent is ethyl, because it contains a total of 2 carbons, ethyl, and is located on the 4th carbon of the parent chain. 4 ethyl, 1 hexanol.